Hi everyone, my name is Jenessa. I did my project on visualizing the interaction between potato crop cover and soil conditions. So as you may know, potatoes are grown underground. This makes them susceptible to soil-borne diseases, pests, and pathogens. Particularly in the Pacific Northwest, we have verticillium wilt, and this is exacerbated by nematodes. So when you have those two in combination, it can be really devastating for a potato field, wiping out potentially up to the entire field or a large part of it. And it occurs in patches. So, but a lot of this is difficult to detect before it's too late. So a lot of farmers treat the soil preventatively. And precision agriculture could be useful in predicting hotspots and developing management zones for treating those hotspots. Right now, a lot of farmers just apply fumigant to the entire field. There'll be a fumigation with vapam, which is very toxic. It's one of the main ways that that these pests and pathogens are treated or controlled. It's not always effective, and it's been noted that it's ineffective at high soil pH above 7.7. And in East Oregon, where there's not very much precipitation, you've got calcareous soils, you're going to have higher pH. So a lot of the soils out there are problematic for fumigation. So I wanted to look to see if it's possible to identify patterns spatially and to develop models for predicting hotspots. So my question, how does crop cover in potato correlate with soil conditions? Can we identify any spatial patterns between crop cover and the following soil conditions? I picked soil pH, soil sand content, and terrain. So the data sources I have, crop cover I got provided by Photography Plus. I've been working with a grower out in the Columbia Basin, and they have all of this data. And then I got some data as well from the NCRS Web Soil Survey. So for the Photography Plus data, the resolution is 0.5 meters. It was orthorectified to very high local precision, so it's probably a custom projection. And when I was georeferencing the images, they were off just on the edges of the field. The neighboring fields were not in line at all. So it was very precise for the particular field, but other than that, it was very not accurate. So soil pH was grower provided, as was sand content, which were both sampled at 1 sample per 2 acres, for a total of about 59 to 60 samples per field. And soil rating I obtained from National Resource Conservation Service, Web Soil Survey, and that has a resolution of 600 meters. And that was in N8083, which I converted to the projection I used. Digital elevation model, I got that from the Oregon Geospatial Enterprise Office with a resolution of 10 meters. Also in N8083 originally. So I just want to give the scales that I'll be using. So I'm going to show you my ARC map, ArcScene, which was a little bit hard to have the scale visible while you're also looking at the maps. So this is soil pH. Just remember that purple is higher pH and blue is low pH. I kind of matched this up with pH range indicators and hydrangeas, which turn blue at lower pH and purple red at higher pH. So sand content, 61 to 98%, and darker content is more like clay, yellow is more like sand. And for both of these scales, I used an interpolation spline function. So it's not exactly as extreme as these ranges. The actual data points that were collected was more around 5.5 to I think 8.7 was the highest. And so these more extreme values are just artifacts of the interpolation, which I'm not quite sure the best way to get rid of those, but so it's not too far off. And then sand content was about 62 to 95%, so it was very high. Then I also had this soil rating. One of the attributes was farmland rating, and they have these different classifications 1 through 7. And included on this site are farmland of statewide importance and not prime farmland. So the projection I used was the Columbia River East in AD 83, course 96, LCC feet international. I was getting the best accuracy with that. And I did all of my analysis in ArcMap and some data analysis in Excel or R. And then I displayed the map in ArcScene because I wanted to visualize the terrain in a 3D model and also use a swiping function. So I published the ArcScene to ArcGIS Online via City Engine so that I can also share it and also enable the swipe tool. So just to go back, these are the legends, and they're on the map. They're on the web link as well, but you have to click, and it's a little bit hard to view it simultaneously with the maps. So, and I have that loaded here. So let me just zoom out. So this is the area that I was looking at, and so north is that way, up, and so I have these 6 fields that I was looking at. We'll go zoom in on field 1. So you can use this swipe function to compare. Right here I have pH, which is purple and blue. So blue is the lower pH, purple is the higher pH. And then I want to compare what does crop cover, which is red. Red is healthier vegetation, and then the blue is not so healthy. So wanted to compare. Is there any pattern going on here? And you can play around with all of these as well in these different. This is sand. Darker is less sand. Yellow is more sand, towards 98% almost. And then I also had soil classification. So green is the farmland of statewide importance. Yellow is not prime farmland. So you have some of both categories. So just trying to see all those different layers overlap. I would like to do an inverse or a weighted layer analysis. Right, so let's look at field 2. Okay, there we go. So comparing crop cover. So yeah, this one does look pretty well matched up with higher pH, which is purple, is matching up pretty well with poor crop stand, and that is very obvious in this case. Now if you can look at the terrain, I guess I have to, you can look at the terrain by, I did exaggerate the terrain by about a factor of 2, twice as much, because it was kind of hard to see any patterns in the terrain in this view. And I'm not sure why there's black corners here, but yeah, so now let's take a look at sand. Not really anything going on with sand there. All right. So, now what I do have over here, I'll check out this one first. So this is one of the healthier fields, and I'm going to look at pH. So the pH is pretty much low in the entire field comparatively. And the portions of the field that have a little bit of patchy dieback right here are kind of close to that higher pH soil. So also you notice this terrain is very flat. Very flat. Right, now let's check out one more field. So this field, was very hilly. So we actually sampled on this field, and we are sampling a grid right here in this corner, or this region. So now let's look at pH. Matches up also pretty well. The high pH over here on the left is purple, and then matches up pretty well with patches of poor crop stand. And you can also kind of see that there are tracks here where it looks like the tractors would be tracking the disease along into the other parts of the field. So it's something for farmers to be aware of, that you can spread disease through a field. So, all right, and you can play with the other two if you want. So my methods had these 5 data sets: infrared, soil pH, sand, soil rating, and DEMs. The soil pH is raw data, which, and then I georeferenced the infrared imagery, digitized field borders. The raw data, I digitized points for the columns, and added the columns for pH and the sand. Then I had points with values for soil pH and for sand. I interpolated these points using the spline function to get maps of soil pH and of sand. I made sure to display all of these fields on the same scales for soil and for sand, so they could compare them. And so then I clipped all of these data sets to the field borders and displayed it in ArcScene using the DEM as a base layer for base height reference, and then published to ArcGIS Online via City Engine. I also did some analysis with the datasets, extracting the crop cover as the pixel values from infrareds at the sampling points and converted it to a percent of 225. So here's the data. You can see decreasing crop cover with increasing soil pH, and then it kind of levels out here. So I wasn't able to get an R-squared value from this because of the function, but shows a trend. All right, there's no trend in soil sand content versus crop cover, R-squared of 0.0013. Recommendations: apply sulfur to lower soil pH in high pH areas, utilize biofumigant, cover crops, and if necessary, my thing's going to cut out.